I am D. Sengotain, Assistant Professor of Physics, SNS, College of Technology, Coimbatore. In this video, we will discuss about design thinking part of laser. So our students explain the empathy part, define and ideate.
I am Mauricia. Here is the difference between ordinary light and laser light explained with empathy. In ordinary light, the light waves are random and scattered. In laser light, the light waves move together in one direction. Ordinary lights are incoherent, waves are out of step, whereby laser lights are coherent, waves are perfectly in step with each other. Ordinary light contains many wavelengths, where laser light has only one wavelength, it's monochromatic. The ordinary light spreads out in all directions. The laser light are very narrow and focused beam, less intense in ordinary light, and laser lights are extremely bright and powerful. The empathetic understanding is imaginary ordinary lights.
Myself Kanisha, and here to give some definition to the topic. Laser. Laser stands for light amplification by stimulated emission of radiation. First developed by Theodor H. Mayman in 1960s, upon the theoretical ideas by Albert Einstein, Charles Stokes and Arthur Shallow. A laser is a device that produces a narrow, intense beam of light that can travel through long distances without spreading much through the process called stimulated emission. Now, what is stimulated emission? It is a quantum mechanical process in which an incoming photon with a specific energy strikes an already excited atom, causing it to release a second photon. This photon is identical to the first with same phase, frequency and direction, leading to coherent light amplification. This is a fundamental principle behind the working of laser. Now to define some properties of laser. Monochromaticity. It emits light of a single wavelength or color, a very narrow band of wavelength. Coherence. The waves are in phase, allowing the beam to stay focused, that is, constant phase difference and frequency. Directionality. The light is emitted in a narrow beam in a single direction and high intensity. The beams of the light energy is concentrated. Lasers can be extremely powerful. It is used in many fields from medicine, communication and industry to scientific research and entertainment. It is one of the most revolutionary invention of the modern science.
Myself Vishalakshi, I am going to speak about types of lasers according to the ideate. There are 6 types of lasers. Solid state lasers like ruby, and these are solid crystal and are widely applied in the material processing and scientific research. Gaseous lasers are gaseous filled tubes, predominantly example helium and neon, are used in alignment and holographics. And for example, carbon dioxide laser vital role for the industrial cutting and welding. Dye lasers are used in organic dyes in liquid form. They are turnable, meaning their wavelength can be adjusted, are often used in research and medical treatments. Semiconductor or diode lasers are used in the semiconductor materials, are common in barcode scanners, laser point and optical communications. They are compact and energy efficient. Finally, fiber lasers used in optical fiber dopant with the rare earth elements. They are excellent for precision machining and medical use due to the power and beam quality.
And myself, Dashi CK, I am here going to explain about industrial lasers. Okay, what is industrial lasers? Industrial lasers are powerful tools that use concentrated light energy to process materials with high precision and speed. They are widely used in industries for tasks like drilling, cutting and welding because they provide accurate result, minimal material waste and clean finishes. Now, we are going to discuss about laser drilling. What is laser drilling? Laser drilling uses focused laser beams to create tiny, precise holes in hard materials such as metals, ceramics and composites. It is ideal for making holes in engine parts, turbine blades and electronic components where high accuracy is needed. And then laser cutting. Laser cutting metals or vaporized metals uses a high intensity laser beam to produce clean and sharp edges. It is used to cut metals, plastics, woods and fabrics. This process is fast, contact free and suitable for complex shapes. And then laser welding. Laser welding joins two materials by melting their surface with a contact laser beam. It provides strong, narrow and clean welds with minimal heat distortion. It commonly used in automotive, aerospace and electronic industries. And then main key points which have been used in this laser drilling. First, laser source, focusing points, CNC or robotic system, cooling system, control software. And nowadays, the industries are most commonly using fiber lasers for their works.
I'm Suchita and I'm going to explain the applications of laser light in the medical field. Lasers are widely used in the medical industry for precise and effective treatments. They are used in surgery to cut and seal tissue with minimal bleeding. In ophthalmology, for vision correction and retinal repair. Organ lasers are widely used in ophthalmology for treating glaucoma and retinal tears. In dermatology, for hair removal, scalp treatment and skin resurfacing. In dentistry, lasers helps to remove decay and whiten teeth. While in cancer therapy, they destroy or shrink tumors using photodynamic therapy. Lasers also treat varicose veins, assist in brain surgeries, and are popular in cosmetic procedures for wrinkles and scar removal. CO2 lasers are employed in surgeries for cutting, vaporizing, or coagulating soft tissues. Overall, lasers provide accuracy, fast healing, and reduce pain in medical treatments.
Hi, I'm Sagar from Aerospace. Here my talk is about lasers throughout the research centers. Lasers, as she said, it has very quiet and unique characteristics. It is the main reason it has been playing a very crucial role on researchers. LIB system. It is full and fully based on lasers.